Hi everyone. In today's lesson, we're going to talk a little bit more of the applications of long division. So we can determine that an expression is a factor of a polynomial by performing long division and showing that 0 is a remainder. This is what we kind of talked about yesterday, but I want to go into it a little bit further. So I'd actually like to start with example number 1. It says use long division to determine if the binomial is a factor. So we're going to do long division and we're going to see if we get 0 as a remainder. So remember, the binomial or the potential factor is going to be n minus 9. So we're going to put that on the outside. And then on the inside, we're going to put the polynomial. So n to the fourth minus 14n to the third plus 50n squared minus 44n minus 9. So we're going to, again, as we do long division, we're going to use the first term with the first term. So how do I get n to multiply to n to the fourth? And you should be saying n to the third. So we go ahead, label it right on top of where the n to the third is, and then we multiply. So n to the third times n, and then n to the third times negative 9. So n to the third times n is n to the fourth. N to the third times negative 9 is negative 9n to the third. And in true long division fashion, we subtract. The n's to the fourths will cancel. So now remember, it's a negative 14 minus a negative 9. So it's going to be a double negative there. So negative 14 plus 9 is really what you're going to type into the calculator. And you should be getting negative 5 n to the third. And then we always bring down that second term. So plus 50n squared. So now still same thing, first with first. So now how many times does n go into negative 5n to the third? So what do I need to multiply n by to get negative 5n to the third? We should be telling me negative 5n squared. So negative 5n squared, now we're multiplying negative 5n squared times n, and negative 5n squared times negative 9. So negative 5n squared times n is negative 5n to the third. Then we have negative 5n squared times a negative 9. Negative times a negative is a positive. So positive 45n squared. And we're going to subtract. So now be careful. We have 50 minus 45. That's a positive 5n squared. We bring down my next term, so minus 44n. And we're always looking at the first with the first. So n first into first. So how do I multiply n to get 5n squared? And you should be saying multiply by positive 5n. And then we're going to multiply 5n times n. That gives me 5n squared. Then we're going to do 5n times negative 9. That gives me negative 45n. And then we're going to subtract. The 5n squareds are going to cancel. And now we have a negative 44 minus a negative 45. So it's a double negative there. So when you do that in the calculator, you should get 1. So 1n. And then last but not least, I'm going to bring down my 9. And then last but not least, we're going to do first with first. So how does n multiply to 1n? All you need to do is multiply it by a positive 1. So then we're going to now multiply 1 times n. That's going to give me n, or 1n. Then we have 1 times negative 9. That's going to multiply to a negative 9. And we subtract. So here the n's are going to cancel, and here the 9's are going to cancel. And we do, in fact, get a remainder of 0. All right, so a couple conclusions that I'd like to write down. The first conclusion is going to be since 0 is a remainder, that must mean that n minus 9 is a factor. So just to write it nicer, since 0 is a remainder, then n minus 9 must be a factor, right? If we get a remainder of 0, then the binomial that's on the outside will be the factor. Now, there's another thing that we can conclude from this. We can conclude that if n minus 9 is a factor, then the opposite sign must be a root. So then n equals positive 9 must be a root. And remember roots, the third conclusion, since n equals 9 is a root, then f of 9 must equal 0. Now, I'm calling f of 9 for general function notation. So f of 9 means that if I plug 9 into this original equation, I should, in fact, get 0. So let's see what happens if we do that. So the polynomial, we have n to the fourth minus 14n to the third plus 50n squared minus 44n minus 9. So if we plug in 9 in for n, we should, in fact, get 0. So why don't you take a minute, pause the video, and type all of this into the calculator just the way you see it with parentheses and everything, and see if you get 0, and then hit resume when you're ready for the answer. All right, so you definitely should have gotten 0. So those are the three conclusions that we definitely want to make if we get 0 as a remainder. So just to recap, if 0 is a remainder, then this n minus 9 has to be a factor. And if this n minus 9 is a factor, then the opposite sign, n equals 9, must be a root. And if we have a root, then if I plug it into the original equation, I should in fact get 0, which I do. All right, let's look at the second example. So same kind of concept. They want to know if the binomial is a factor. So why don't you guys pause the video and do the long division and see if you get 0 as a remainder. All right, take a look at the work. Here it is. Okay, so it looks like we have the similar situation in example number 1 where we have a remainder of 0. So that means three things. The first thing that it concludes is that p plus 10 must be a factor. Okay, then it concludes that the opposite sign, p equals negative 10, must be a root. And the third thing that it concludes is that f of negative 10, if I plug in the root, I should get 0. So let's test it out. So we have p to the fourth plus 19p to the third plus 85p squared minus 47p plus 30 and negative 10 to the fourth plus 19 times negative 10 to the third plus 85 times negative 10 squared minus 47 times negative 10 and then plus 30. So go ahead, pause the video, type all of this into the calculator just the way you see it, and you should get your remainder of 0. Okay, so let's try one more example together, which we'll say is example number 3. So now I'm giving you the same information now. So use long division to determine if the given value is a root or a 0 of the function. So now I'm giving you the root, and I want to see if I can determine if it's a root or not, right? So we could use long division to do this. So if the root, so we're going to put like the root in quotation marks because we want to determine if it's a root. So we're not sure yet. So if we have a root of v equals 9, then what would the factor be? Then I'm going to put in parentheses or air quotes, then the factor would be v minus 9, right? The opposite factors. So let's take a couple of minutes and do the long division with v minus 9. So v minus 9, right, we have the polynomial function 3v squared minus 30v squared, v to the third, plus 28v minus 2. So take a minute, pause the video, and do long division, and see if you get a remainder of 0. If we get a remainder of 0, then v equals 9 has to be a root, because v minus 9 would be the factor. So again, pause the video and see what you get for your remainder. Okay, here's your answer. Okay, so you should have got what I have here, that the remainder is in fact 7. So what that implies is a few things. So first things first, since the remainder is not equal to 0, then v minus 9 is not a factor. And if v minus 9 is not a factor, then the opposite sign, v equals 9, must not be a root. So v equals 9 is not a root. And the third thing is that if I did f of 9, I would not get 0. So let's plug it in and see what we would get. So we've got 3v to the third minus 30v squared plus 28v minus 2. So if I were to plug in 9, I want to see what I would get. So take a couple minutes, plug this into the calculator, just the way you see it, with parentheses and everything, and then hit resume when you're ready for the answer. Okay, so when you plugged it in, you should have gotten 7. Now, 7 should be ringing a bell to everybody here. You should be recognizing that this 7 and this remainder are the same thing. So this is actually called something. It's called the remainder theorem. So although f of 9 doesn't equal 0 in this particular case, f of 9 will actually equal the remainder. So if you want to write that down, f of 9 will actually equal the remainder, right? It's not going to equal 0 because the remainder wasn't 0. So in this particular case, when it's not that, you're going to get the remainder to equal the value when you plug it in. So how could we use this to answer a question more quickly? So let's look at this example here, example number 2. I know the question says use long division to determine if it's a root or a 0, but let's use the remainder theorem. The remainder theorem tells us if we plug in the potential root, so plug in root, putting it in air quotes because we're not sure, so plug in root of x equals 1 to get the remainder. Right? So we're taking 10 times 1 to the 4th minus 4 times 1 to the 3rd minus 11 times 1 squared plus 5. So take a minute, pause the video, type that into the calculator, and hit resume when you're ready for the answer. Okay, so we get 0. So what that tells us is that x equals 1 must be a root because f of 1 in fact equaled 0. 0 would be the remainder if we did long division with x minus 1, the opposite sign. So I know it says use long division, but this is called the remainder theorem where we could actually get the answer more quickly, especially if the directions don't tell us to use long division. Then we can use that instead. All right, that's it for tonight. If you guys have any questions, please jot them down, and we'll see you in class tomorrow. Have a good night.